Alright, back with a little bit of implicit differentiation. So remember the aim to find dy dx. Got to watch out for our product rule, got to watch out for our chain rule. We should be right though. Let's just go through step by step and make sure we can get this one. So first terms here, I have a product. I've got x cubed and I've got e to the power of 3y. So let's do the product rule on that. So the derivative of the first one, d dx of that we can find. Remember, that's what we're doing. We're finding d dx of every term. It's nice if you can write it on either side, but that's fine for that sort of notation as well. So d dx of x cubed is 3x squared, and I'll leave the second bit alone, e to the 3y. Then other half of our product rules, that was u dash v. Now we have to do plus uv dash. So I leave the x cubed alone. The derivative of e to the 3y in terms of x, I do d dy of that. So it's 3e to the 3y multiplied by dy dx. And there's that dy dx term that we're looking for. Might not be the only one, we'll keep going and see what we get. Next term, 4x squared plus y cubed. So again, we've got a product there, 4x squared, but not plus y cubed, multiplied by y cubed, so that's a product. Derivative of the first bit, derivative of 4x squared is 8x. Leave the y cubed alone. And then we leave the 4x squared alone. And we go d dx of y cubed is 3y squared by dy dx. Again, that's our chain rule in action there. Right hand side of the equation, not so bad. The derivative of that, 27 by negative 2 is negative 54 e to the negative 2x. Remember, the power always stays the same with all of the e functions. There we are, we're almost done. So it seems quite hard, but it doesn't take us very long. What are the terms that we've got to get together? These terms containing dy dx. The rest of them we'll get on the other side. We'll factor out the dy dx, do our division, we'll be done. So it won't be too bad. Not red pen, let's go back to black pen. Thank you. So I'm going to leave x cubed 3e to the 3y plus 4x squared 3y squared dy dx. On the other side I've got negative 54 e to the negative 2x. I've got to subtract 3x squared e to the 3y and subtract 8xy cubed. Now we're almost done. Doesn't look very pretty, and we might be able to pretty it up, but let's just do dy dx. That's all we're really being asked to find. Negative 54 e to the negative 2x minus 3x squared e to the 3y minus 8xy cubed. When I don't look at what I'm writing, it does get a bit messy. Maybe I'll get better at it. And we're dividing by that coefficient of the dy dx, which is the big, let's make it look a little bit nicer, 3x cubed e to the 3y plus 4x squared by 3y cubed. Oh, well, why didn't I make that? Why didn't I make it 12? What was I thinking? 3 4s are 12. X squared y cubed. That was an x as far as I can tell. Yes, sorry for the penmanship. My stylus isn't quite calibrated perfectly. But there you go, you've got an expression for the derivative. Not a particularly pretty expression, but it's one that you can use to then go ahead and find stuff out. Could I factorise things out of that? Let's say it asked you to factorise in the exam. It may do. It probably won't for that sort of thing, but it may do. So let's have a look. On top, well, I can take out a negative. No, nothing. There's nothing really I can take out there, so probably you're not going to be really factorising that one. The bottom we could certainly factorise a little bit. 3x to the x. I'm sure that's not right. What did I mean to write there? 3x cubed. Look at that. Penmanship. 3x cubed e to the 3y plus 12x squared y cubed. Well, you could take out 3x squared if you were really keen. But again, it's not going to factorise out at the top, so I'd probably just leave it. No need to make it more complicated and risk making a mistake where you don't need to. There you go, that's it. Have fun. I think I've got one more question waiting in Edmodo, so I'll finish that one off. And then I'll see you in the next video whenever you ask your next question. Cheers.